Hey guys, we're back at the John Jay High School Robotics channel. Let's go. Today we have encoders. We're going to be using encoders, how you can code them, and maybe give you a demo of the robot too. We'll see, I guess.
Using the encoders. We used encoders on our robot last year, so it's possible that we can show you guys how we actually did that once we get into this a little bit. So,
All right.
see you
Let's
then.
go.
All right, guys, we're here with our program. I haven't done anything yet, except I declared the motor as we did in the previous video. Go back and watch that if you don't know how to do this stuff that I'm highlighting right now. So, yeah, we're just going to make this move using the encoder instead of setting the power like we did last time. So, to start, what you want to do is you want to reset the encoder value to 0. So basically, if you stop running a program and then you rerun it, the encoder value is not going to reset from before. So at the beginning of our program, we want to make sure that we're resetting the value of the encoder to 0. So to do that, you just write as follows: motor, which is our variable, dot set mode, like that. And then you want to do parentheses, DC motor, dot run mode, stop. That. And that should reset the encoder value to 0 at the beginning of the program. You also have to do this in the initialization of your program, because otherwise it's going to be, if it's inside the while loop, it's going to continually reset and your program's not going to work. So yeah, just make sure you're doing that in the initialization and it's above the while loop. Another thing you can do, which we didn't talk about this in the last video, but I feel as though it's good to mention now, is that you can set the brake behavior of your motor. So basically, when it finishes running a command, it can either brake really quickly or it can slow down slowly. So the way you can do this is motor dot set 0 power behavior, and then you want to do DC motor 0 power behavior. And then, so there's two options here. You can do brake. So if it's stop brake, what that means is that once the motor reaches the end of a motion, it's going to stop really quickly. It's just going to lodge. It's going to lock up. What you can also do is you can set this to float. This is the default setting. So if you have this already, you don't actually have to type anything if this is what you want. But what this will do is it'll not brake, and when you reach the end of your function, the motor will slow down gradually.
Torque,
yeah. It's not gonna lock up like it will. For now, we're gonna do brake for demonstration purposes. It makes it easier to see the rotation of the encoder. So the next thing you're gonna want to do is you're gonna want to set the position of your motor and how far you want it to turn. So that's just done like motor dot set target position. And what we want to do for now is we want to make the motor turn 1 rotation. So I'm not exactly sure how these are measured, but 1 rotation is 1,440 units. So you can just use that as reference. 2 rotations, it would just be like times 2. 3 rotations, you can do times 3. If you want to do half a rotation, you can do times a half. But 1,440 is just 1 rotation. That's really all you need to know.
It's essentially like its own degree system. Like in a circle, there's 1440 degrees.
Yeah, that's a great way to put it. So, but this doesn't actually turn the encoder. This is setting the target position so that later we can turn it. The next thing you want to do is you want to set the mode of the motor so that it will turn using the encoder. So you want to do motor dot set mode DC motor dot run mode dot run to position. And what that's going to do is that's going to tell the motor, hey, we're running 1440 units and we're running using the encoder. And all you have to do is set power. And you can set that power from -1 to 1, although I should say something about that. When you are using encoders, the negative doesn't matter. It will always run in a direction towards your target position. If you want the motor to run the other way, you can set the value of the encoder to be negative like that. But setting the power negative or positive isn't going to do anything. So what we're going to do here is just set the power to 1. It's going to, okay, like that. And that's all. That's the whole thing. So when I run this, what's going to happen is the motor is just going to turn 1 rotation and stop immediately. So if we compile that, it should work. And we will see you guys in a second when we run this code.
Okay, so we're here and we're gonna make this motor move. So the first thing we want to do is make sure our control hub is on by flipping the switch and seeing that this is lit up. So see how that's flashing? That means it's on. So that's good. Then we take the phone, and what you see here is that this program is set to motor test.
Well, yeah, we gotta wait for second 2 as well because it's gonna get to
The Wi-Fi.
the Wi-Fi.
Yes, but
while we're waiting, you can just mention.
what you have to remember to do is that if you remember from before, we made a new program, encoder test. So we have to remember to press this drop down, and
It's not gonna be there till
it's not going to be there because there's no Wi-Fi.
we're technical difficulties. We are waiting for Wi-Fi. Also, by the way, for note, so I've made this green marking on it so you can see when it comes back to the top when we run the encoder, it should do 1 rotation. So you'll see like the green back on the top again.
So back to this.
Okay.
We're connected to Wi-Fi. Sorry about that. You have to remember to set the program to the right thing. So you have to press here. Then we were using encoder test. So that's the program. So that's a different one than we were using before.
Yeah, but if you scroll back in the video as well, you can see how David was in another file when he was editing his stuff. But yeah, anyways.
Just important. You should always remember to do that.
All right, so now we're going to run it.
Run the code.
And you see right there, it goes 1440 because the green comes back on the top. So you can run it again if you want. You can watch.
It is 1 full rotation, and it will stop. I haven't stopped running the code. The code is still running.
Yeah, you can see.
But
the motor has stopped.
yeah.
So yeah, that's encoders.
That's all there is to it. You can do a lot of really cool stuff with this. We can get into a lot more detail using Boolean logic and complicated Java stuff to make them turn multiple times, turn back, sideways. You can make wheelbases move. Yeah, but this is a very fundamental concept, and if you know how to do this, it really opens the gate to doing a lot of things.
Especially in autonomous.
Especially in autonomous. This is very important in the autonomous segment of the FTC competition.
All right.
So there you guys have it. We made an encoder, and we used it to move the motor with run rotation. And what we did is we set the motor to move a certain number of degrees so that it will stop moving once you reach the point that you want it to move.
Yeah, and next video, we're probably going to be talking about sensors. There's a bunch of them like range, gyro, touch. Yeah, lots of fun stuff. Hope you guys are looking forward to that. We didn't get to implement it a lot in our robot, but we think that probably could have been really good if
and
we
also,
got to.
I think if you guys have more time in the competition coming up, you'll have time to figure out those sensors a little bit better and incorporate
Utilize
them
Yeah.
in your autonomous, especially in ways that are kind of in some ways better than using encoders.
Or they can also aid you with your encoders
Yeah.
as well. Anyways, we'll see you next time.